talk on program outcomes, knowledge profile, complex engineering problems, and complex engineering activities, alignment to academic curriculum. Before we begin, to all our Muslim attendees, let's take a moment to recite Surat Al-Fatiha to commence our talk today. All right, just a kind reminder to all attendees, please keep your microphone on mute unless you are talking. Okay, so during the session, our speaker is going to take several short breaks, and this is to take some questions from the audience. So during those breaks, you can ask verbally using a microphone, or you can also type in your questions in the Webex chat, and I will actually convey the questions to our speaker. Now, before I hand over this session to IR Liew, let me introduce our speaker. So, IR Dr. Liew was a practicing engineer who later became an academician. Okay, he is currently the head of internal quality audit for engineering programs at Xiamen University, Malaysia, as well as an associate director of the Board of Engineers, Malaysia's Engineering Technology Accreditation Council. So actually, he graduated from UTM, okay, with a PhD in engineering education. Okay, so since 2012, he has been involved in the accreditation of engineering degrees, engineering technology degrees, and engineering diploma programs. Okay, he has given over 60 workshops and talks on accreditation, outcomes-based education, and complex engineering problem solving to the Engineering Accreditation Council (AC), the Engineering Technology Accreditation Council (ETAC), Malaysian universities, the Board of Accreditation for Engineering and Technical Education Bangladesh, and many others. Okay. He also acts as an external examiner for various universities' undergraduate programs. He has over 12 years of teaching and academic experience and managing engineering programs and 12 years of industry experience. Okay, all right. So that was a brief, what we call bio of our speaker today. So we are very honored to have you here today. Okay, so without further delay, I cordially invite Ayah Dr. Liew to give his sharing session. So over to you.
Okay, thank you, Dr. Osman, for the introduction. Can you hear me okay?
Yes, loud and clear.
Yeah.
Yes, and
Okay.
your slides are also okay.
All right. Okay. A very good morning to all the participants here today. I believe you know everyone here, from my conversation with Dr. Professor Robita, is that I'm here to address the issue about alignment. You may be experiencing this, whereby you have the courses to PO mapping, then you add in the courses to knowledge profile mapping, and then you add in the complexity mapping, the WP, then complexity mapping again, the engineering activities, and there are so many mapping. Yeah. Initially, all these knowledge profile and complexity attributes are actually given for guidance. Somehow, there are too many mapping until we can't understand what is actually happening. I believe this is the one that you are currently experiencing. Yeah, right. Before I begin, right. I think Dr. Osman already introduced that. I think the main title here today is alignment to curriculum. I will talk about complex problem solving, but it just the surface, because I want to focus on the alignment, for today, yeah. Okay, so I basically put I have been with some university as an external examiner, also in my own. So I actually find out that there are actually 5 steps to the alignment, yeah. All right, so this is through my experience and also my own reading, yeah, right now. Okay, so I will talk about this one again. So just give you an overview of what's gonna happen today is that you see the knowledge profile simply means that the components of the curriculum, yeah, it's just the curriculum that we need to cover, yeah, courses to cover the knowledge profile stipulated by EAC, right? In fact, it was stipulated by the International Engineering Alliance, the alliance that formed the Washington Accord. Also, we need to include other courses to demonstrate the program outcome. For example, teamwork. All right, you may have assessment to do so. Yeah, project management, even the lifelong learning. Yeah, those courses to demonstrate program outcome. These are not actually included. Teamwork, communication. They're not part of the knowledge profile, but we need to include that because the program outcome include those attributes on communication, teamwork, and so on. After which, we need to design, the courses to the course learning outcome that align to the program outcome, right? Then we talk about the complex problem solving, yeah, whereby it will be under the assessment and teaching and learning activities, right? So the aim here, we must be teaching enough, all right, in the as per the knowledge profile, right, so that they are able to solve the engineering problem and even carry out some engineering activities, right? And here again the teaching, the assessment, teaching and learning need to align to the course learning outcome. And I think there's one key thing here. We have to design the assessment with the required characteristic, yeah, which is all the WPs, yeah, the complex attributes, yeah, complex engineering problem attributes, the complex engineering activities, right? And the reason why we need to do this is that because the 12 program outcome, there's a special words being tagged along is that special words, complex problem solving, yeah, in the first program outcome, second, third, fourth, fifth, sixth, seventh, yeah, it been mentioned. So the reason why we have to design the assessment with the required characteristic is for the student able to solve complex problem solving. Yeah, remember the program outcome needs to be demonstrated at the end of the program. If you look at I think in the spectrum of engineering is that in the spectrum is that you have engineers, you have engineering technologies, you have engineering technicians. They are all differentiated by the knowledge profile. Yeah, for example, yeah, right. The engineering technician knowledge profile at the current moment does not include research, right? Therefore, the program is actually like 2 to 3 years. Yeah, 2 to 3 years. And furthermore, because the engineering technician, they are taught to solve a problem which are very close-ended, very well defined, and therefore the duration of study is much shorter than engineering. Okay, and according to IEA, the program that build this type of knowledge and develop the 12 program outcome is typically achieved in 4 years of study. What this actually means is that you need this knowledge profile in order, all right, minimum knowledge profile in order to solve, to demonstrate the 12 program outcomes, which include the capability to solve a complex problem, right? So that will be the overview. Yeah. Now, so there's a panel here. How do I hide the panel?
So the panel on the top of it, is it?
Yes, I think now it's gone. Yeah.
All right. Okay.
Gone.
It auto hides. Yeah.
Okay. Right. So, oops. Okay. Right. Okay. Now, I think the first step is that we need to know whether the courses you're teaching fall under which knowledge profile. I think this is the key thing here. I think most of the time is that we are unable to classify them. Therefore, we have problem with setting the complex problem, even aligning to the big mapping that we always have, courses to program outcome mapping, right? So this is one example, right? So this is one example taken from my own university. I think the first thing that I did with them is that I classify the courses. Yeah? For example, I make we have a discussion on a program level because myself alone cannot make that decision. Yeah. For example, we actually decide a programming language to be under fundamental, all right, rather than at times it can be mathematics. Yeah, depending how you want to do that. If the programming language is used to solve to make calculation, so probably it will put that under mathematics. But here I use that to solve engine problems, so I put that under engine fundamental. This is what we have decided. Um, Electrical engineering we will put under engine fundamental, right? Maths is very clear cut. It's going to be mathematics, right? So engine physics very clear cut. It's going to be natural science, right? This is what we have done. Um, some of my colleagues is that if we have a subject like microelectronic devices, all right, it can be actually two, yeah, natural science and engineering fundamental. The reason provided by my colleagues is that I need to do some physics first, semiconductor before I can do this, yeah. So therefore, he has two ticks, right? I think the key thing here is that we need to um, my advice is that we take as less as possible so that we won't get confused. Yeah, we must know the dominant, the subject, the dominancy. Where is that? Right? You can actually take a lot of stuff. You can actually take a lot, but we must understand that the dominant, yeah, component of the knowledge profile. Yeah, so at times we said, oh, engine fundamental, electrical engineering, but in the class I teach a student about design, so I may take that. So you may have to take, but you must know that the dominant one is the engine fundamental, right? So we will talk about this a bit more. I have here engineering society. Okay, engineering society is very clear to me. It's actually the WK7 is comprehension of engineering in the society, environment, health, and safety, and so on. Yeah, right. Now, the common issue is that with the faculties is that about knowledge profile is actually what is it? It first introduced. What it is. Why is that needed? Yeah, why is that needed? How to address that? I think these are the common issue that I heard from the school or the faculties. Yeah. Now, I think before I begin, I will give a definition of the knowledge profile, actually compiled through various sources, and particularly from the International Engineering Alliance and also the Canadian Engineering Accreditation Board. Okay, so it basically say that it's a broad characteristic of the different component of the knowledge embodied in the program, right? It's actually meant to provide us with the guidance on curriculum design and review. In Malaysia, yes, we sort of have that. If you are familiar with the Engineering Accreditation EAC program accreditation standard, you will see in the Appendix B. Yeah, it will sort of give you some kind of guidance. All right, that is the Appendix B. The Appendix B, right? If you are familiar with the accreditation manual, and according to the Canadian Accreditation Board, is that it can be viewed as describing what the curriculum of an engineering program must contain at a minimum. So basically, this is just an accurate curriculum, right? Nothing to be confused of. Yeah, it's just the contents of the curriculum. Yeah, and the common problem here is that with the educators is that what are the differences, right? So what are the relationship between the specialist knowledge, engineering fundamental, natural science, and mathematics? Yeah. So these are the common issue. Now, why do we need to map our courses to the knowledge profile? In fact, I wouldn't call this mapping, but rather is listing out. Yeah. But somehow, at times goes by, it's actually more convenient for us to map. Yeah, to do the ticking. In the past, I implement that natural science. I just list down the course. mathematics, I just list down the costs. But now I think mapping is actually quite convenient. It's not meant for complicating things right now. Okay, as I said earlier, that is the minimum. Yeah, that minimum knowledge that must be present in an engine curriculum. So the mapping is that for us to address the 8 knowledge profile component, yeah, as simple as that. We do not want a program, without the without mathematics, without natural science, if you without in the bachelor degree, probably in the foundation year it has been covered. Yeah, all right. Okay, we have to ensure it has courses that address the last bit WK8 research literature. All right. So to ensure that we address all the noise profile component. That's it. Yeah. Now, the second thing is that to actually help us in designing assessment, complex problem solving. If you know this, then you can actually design assessment, right? Correctly. All right. And that is the purpose. To me, that is the second purpose. Now, how do we map? Okay, how do we map? The question is that how do we map? Yeah. Here, I abstract directly coming from the ESE manual is that there are basically 8 components. Today, I'm going to talk about 8. Yeah, it's not based on the latest which will be implemented in 2024, whereby there will be 9. Let's focus with the simplest one first. Now, you have WK1, K2. This is a knowledge. Yeah? W simply means in Washington only. K is a knowledge. Yeah? K1, K2, K3, K4. Right. And these are natural sciences, mathematics, the engineering fundamentals, the special knowledge for practice. Yeah. The engineering fundamental for many engineering discipline, they share a few similar ones. Yeah, that explain some of the institutions they have the common first year, right? And this is when the courses, the discipline actually separated, by several chemical, mechanical, electrical, and so on. Now, I actually put this first 4 as the knowledge, okay, and following that will be the application of knowledge. Without this, without the knowledge, we can't apply. So the thing is that comes in engineering design, right? That engineering practice and comprehension of engineering in society. All right. This normally present in the capstone project or the integrated design project, yeah, whereby we are teaching the student about the design process, right? About the circuit that always that can be used, our past experience. If you look at the civil engineering, they have the special code for design, the Euro code, for example. All these here actually pass through experience. Yeah, I believe electrical also have a certain design code as well. Yeah. All right. Now, that will be the design, engine design. Following that, you must have the engine practice technology. Here, it simply means the component that we use, the software that we use, the equipment that we use to enable the solving of the problem. Yeah. Otherwise, we can't do the simulation. We can't actually put everything on the board and test it. Yeah. This is the engine practice. Yeah. And the student also need to be aware, not only aware, need to know about the comprehension of engineering society, because whatever they're doing here in the design, they have to consider the factor like public health safety, impact of their solution to the society or even environment, considering sustainability in their design, and so on. Right? Without this, I think the environment will be compromised. The solution will not be sustainable for the next generation, and so on. Yeah. All right. So therefore, this 5, 6, 7, I will put under the application of knowledge, the correct application knowledge, with the consideration of environment, sustainability, and so on. Yeah. Okay. So we to be honest, we can't actually teach students so many things. So therefore, we have to somehow, in the curriculum address how do they source for knowledge. Yeah, this is through the, for example, FYP. We want them to engage with the literature, research literature. We want them to know where can they find information. Yeah, so this is part of the curriculum, right? So that will be the sourcing of knowledge, yeah, research literature. So basically, all these 8 components. Now, so how do we identify the courses under natural science? Example, yeah. By the definition, IEA 2021 is that, so here is include physics, mechanics, chemistry, earth sciences, and biological sciences. Yeah. This, I think most of the time we have physics. Yeah, most of the time. I think in some program in biomedical electronics and also on, they may include the biological sciences into the program. Is actually very much dependent on the discipline of the program. Yeah, I think this is quite easy when we see physics. We put that under that. Even though some argument can be under advanced applied physics and so on. That I think I have colleagues actually argue that the physics that they teach actually apply in solving engineering problem. Then no problem. We can actually put them under WK1, even put them under WK3, right? It's perfectly okay to have two. Yeah. Now, I think we for WK2 is very easy for the maths. We can basically put almost everything right there. Yeah. Everything that concerning maths. Even sometimes the MATLAB, can be put under here because it's to solve the mathematical equation. It can be part here as well, right? Now I think this slide here is very important. To me, is that this is where the slide will help us to understand. Yeah, this here comes from Professor Hu Hanrahan, who was the past Washington Accord chair. So he conducted a survey throughout, I think, his area, and he found out that there are 16 engineering fundamental. There are some linkages between a few fundamental. But for the case today, electrical, I think the fundamental here will be the computing and software, signal and system, electronics, electromagnetics, electric circuit, electrical machine and system, right? And even I think sometimes we do learn about material science, right? We do learn about that, and even some mechanics at the very beginning. All right, this is according to his compilation. There are 16 of them. Yeah, and you will see that for example, mechanics of fluid is actually shared by civil, chemical, and mechanical. So the engineering fundamental and normally present at the early years. Yeah, as I said, that's why some institutions offer the common first year, right? Okay, even the mathematics can be common as well. Yeah, now. Okay, now let me go back. So I think this will help you to put to put the courses under the WK3. Yeah. Now, what about WK4? If you look at some example coming from ESC Appendix B, I think I can easily put the power electronics, electrical power generation, high voltage engineering, power system analysis. I can put, sometimes you may have, digital signal processing. Those, can be the specialist knowledge. Yeah, that you can achieve. Take it from the ESC Appendix B. Even some elective, it can be placed under here, right? So once you're done with the K1, K2, K3, K4, I think your life will be much simpler by classifying them this way. Yeah. So as I put down at the beginning, this one, right? Okay. This will help you in designing assessment with complex problem solving later on. Yeah. Okay. Now, coming back to here. Now, so the question is that can these courses address others' knowledge profile? For example, WK5, WK6, right? WK8, right? Okay. Now, the thing is this, say one a professor argued that I teach student design in power electronics. Okay, fine, no problem. So I can he can actually put down WK4 and WK5. No issue with that. Yeah, and say power system analysis. Oh, I teach students to use simulation software, for example, right? I may put WK6 as well, right? So it's okay. Yeah, it's okay to take this way. I have some elective, right? I have some elective. Maybe let me think about it. Nanotechnology, I'm not sure. Okay, maybe nanotechnology, something like that. So I want to do something. I want to ask students to do some research literature on that, because those are, sort of like a forefront, of engineering. So I may actually take WK8, right? So I will have two components. Okay, no problem with that. Yeah, it can be done that way. All right. So, but I think, the key thing here, we must remember what is the dominant, of each. Yeah. So we can take the rest, but we must know the dominant one. Okay. Actually, taking lesser is better, Otherwise, from my experience, is that people get confused when you take too many. Yeah. All right. Okay. Now, okay. Until now, any question before I go to the next step? Dr. Osman, is there any question from the chat?
Currently, no questions from the chat. And attendees, feel free to
Are you
write your
hearing me okay?
questions.
Am I still
yeah, very
online?
clear. Yes, very clear. You can hear me, right?
Can't hear you, Dr. Osman.
Dr. Liew, can I ask? Can you hear me?
I think I can't hear you for some reason. Hold on. I forgot to turn on. Okay, Dr. Osman, sorry.
Okay, so
I mute myself.
Okay, so there are no questions in the chat, but there's someone who wants to ask you a question verbally. All right, please go ahead.
Dr. Liew,
Yes.
you mentioned on the
Dr.
WK,
yes. Yeah.
And does each course need to have both knowledge and applied knowledge?
Again, your question, Dr. Sarifa? Applied
You
knowledge
mentioned
and
just now for the courses, you gave an example of power electronics and power system analysis.
Yep.
You put WK4, WK5, WK, I think 3 and 7, I can't remember. But my question is, each courses needs to have both knowledge as well as application of knowledge.
Okay. You see, the thing is that I would prefer just one, partly because, even in my own institution, if you try to, I will begin with one. Yeah? I will put the dominant. Yeah. If you see my mapping earlier, I keep that to the minimum. I would actually, to me, my practice is that I will keep to one. Yeah, I will keep to one. But in some situation, because we are human, some professor will want to have two, right? I think we can accommodate that. No issue with that, right? But to me, is that I will put the minimum. Yeah, I will. For example, the integrated design project, I will just put under WK5 engine design. I will just put under WK6. All right. I wouldn't touch on the WK4 specialist knowledge and fundamental, even though the student actually need the fundamental and special knowledge to solve the project given to them. But I will emphasize the integrated design project, or what the so-called capstone, to be under K5 and K6. Okay. Did I answer the question, Dr. Sarifa?
Yep. It means that if I can sum up what you mentioned is we have to decide what is the dominant
The
knowledge
dominant.
profile.
So, I think we need to understand what we're doing. Otherwise, it's very difficult to justify that we want to map more to the WK. Because that course itself, power electronic, is to basically impart the knowledge of power electronic to the student. Design actually come a bit later, or design comes second. Yeah, that's why sometimes the professor want to include that. I teach this, power electronic design, in addition to the power electronics knowledge. So I want to take two. No problem. We can accommodate that. No issue with that. Yeah. Okay. So, Sarifa?
Yeah.
Right. Okay. Right. Let me go back. Okay, now. See, once we have done with that, I think the issue now will be the when we put everything together. All right. I think that will be the confusion will come when we try to put everything together. When we try to put the mapping of the courses of the knowledge profile to the courses to pure mapping. This is where the I think this is where the confusion actually comes. Now, so I'm going to give you some example. Say, and this is the courses to program outcome mapping, which we have been practicing for a long time. Yeah, for a long time, this is what we have done. Yeah, and there are some words being tagged, here. Yeah. And in fact, these two items also is actually quite confusing, because they include the K1 and K2 into that. That gives the confusion that maths and natural science need to be used to solve complex problem solving. But I have the explanation, it's not meant to be this way. Yeah. In fact, I will stick to WK3 and WK4 for the complex problem solving. Yeah. All right. That will explain a bit later. Now, this is a mapping here. All right. So let's take electrical engineering. Yeah, and right here. Okay. Normally, I would want to deliver the knowledge and outcome of a problem analysis. I want the student probably do some simulation, the introductory simulation or in the lab, So that's why I'm taking these three. Very likely, I have 3 course outcome, 3 to 4 addressing this, right? Very likely, right? Okay, now. So just now, we put electrical engineering, okay, under engineering fundamental, right? WK3, right? So, so we want to put them together. So what will happen is that, now, hey, I have here my course outcome, K6, right? I think it's not a problem with this because mine is WK3, no issue, right? But what about here? Okay. Some program may want to go back, they want to go back and take here. It's actually no problem with that, yeah, because they want to be consistent, yeah. But to me, I would just stick to this, right? I would just stick to this because of the dominant idea that I have, yeah. All right, I will just stick to that. It's okay for me to have more than 2 usage, right? If you think about it, it doesn't make sense if I teach electrical engineering just for these 2, right? Probably without the lab, yeah, it doesn't make sense, yeah. So one of my outcome will be more than 2 usage, yeah. So I will stick to this, all right. But some program they want to do this, okay, no problem with that. It's actually not a problem, yeah. But I can keep it right here, right? So the answer is that either you keep to just WK3 to satisfy various party, in the program. I think there are many parties, so you can just take this. But for us is that we must understand this is under WK3. All right. Okay. Now let's look at other example. Now say digital electronics. All right. Again, another fundamental, we have PO1, 2, and 3, right? And we know that PO3 is design WK5, right? Now, if you look at the mapping, this mapping here, I put the digital electronic under WK3, right? Based on the chart that I show here, this one. Based on this, all right? I know that digital electronic, analog electronics will be the fundamental, right? That is the noise profile component I want to address, right? So now going back, I have WK5 here because I really want to do some very basic design. I give a problem to the student. I give a complex problem to the student. At that level, it's actually complex to the student. First, second year, I ask them to design counters that able to do the 12-hour, 24 hours, format, things like that. Yeah, ask them to choose the different type of flip flops. Yeah, in the design. Yeah, at that level, is considered quite good for them. So when I look back, okay, I have the engine fundamental. This is what I've done, right? I can put here, no issue, engine design, because it actually tagged to PO3, right? As I said, to satisfy probably, for consistency or satisfying different parties, then we can actually take here. No issue with that, yeah? But we must know that this subject here fall under here, right? The fundamental, right? Okay, industry training. Wow, right here. Industry training, PO6. This is engineering society, right? And that other element, teamwork, right? Teamwork. Communication, where they need to write report, they need to communicate, and also about lifelong learning right here. Yep, lifelong learning right here. Okay, so the different program will map that differently. They have different emphasis. Yeah, but I just want to tell you one thing here. The idea here, PO9, 10, and 12, they are not governed by the knowledge profile. All right, I think this is okay. You don't have to map to any WK. They are not even governed by that. Yeah. So the important thing, this is PO6, which is WK7, right? So in the industry training right here, all right. So I put, earlier I have identified industry training is for comprehension of engineering in the society, right? If I go back to the PO map, I just cross check on it, all right? To sort of a consistent, right? To just for cross checking, all right? To me, I try not to make that too perfect, until there will be too many changes until everyone get too confused with the thing. Yeah. Now, another one, capstone project, integrated design project. Yeah. Let's look at the noise profile map for this one first. Now, I have engine design, I have engine practice, I have comprehension of engine in society. So here, definitely the integrated design project going to teach them about design process. And here, they have to build prototype model and so on. Definitely going to use some the components, the equipment, the simulation and so on, right? And here, as I mentioned earlier, when students do design, they have to consider public health, safety, environment, sustainability of the solution, and so on. So these are the three major tick of the capstone project. Yeah. Remember, this is the application of knowledge. Okay, of knowledge. Yep. Remember this. Yeah. So when I go back to the big mapping courses to PO mapping, is that I have design, yes, no problem. WK5, engine design. I have this, no problem. 6, engineering practice. 6, 7, no problem. Yeah, WK7. All right, I can have the other element 9, 10, 11, which is not governed by the knowledge profile because I want to deliver the teamwork. All right, I want to assess the communication. I want to have student I want to see how student manage project. All right. So this is a cross-checking that I mentioned. Unless it's a serious flaw, then you make the amendment. Yeah. Okay. Now, the result, is that acceptable this way? The result will be like this, right? You have the program learning outcome. You have the knowledge profile. I think this is quite straightforward. You just do all the ticking this way. I would to me this is kind of acceptable because the knowledge profile, which is the curriculum, once it's set there, it hardly actually change. One is set there unless you revise the curriculum, right? Okay. I think for program learning outcome, if for the learning for the program which are already matured, I think this one also kind of set in. Yeah? It doesn't, it actually doesn't change much unless you're revising it, right? Okay. So any question at this point, at this moment?
Yes, there is one question.
Yeah.
Okay,
Yeah.
it says as follows. Okay,
Mm.
is this a dominant way of mapping acceptable and understood by all EAC panels? Because there are too
Right.
many gray areas and
Yeah.
personal preferences by EAC
Yeah.
panels, so there
Yeah.
might be penalties when courses are not mapped properly
Okay.
according to the panel's understanding and interpretation. So,
Okay.
what's your comment on this?
Yes. The thing is this. I think most of the time is that is the when even though I'm actually involved in EAC or the ETSC, somehow I worried that the panel will have different different understanding on this. But one thing that I always emphasize to my colleagues is that you must be able to explain what you're doing. You must be able to justify. Yeah. When you're explaining this, you must be confident. Yeah. I think this is how we can do that. Some of the practices actually come from their own uni. It may not be applicable to the other programs in another institution. Yeah. So I think the key thing is that the academic staff need to know what they're doing, need to understand, and they must be able to explain why they're doing certain things, right? Otherwise, people won't be convinced with that, right? Okay. So if in some program maybe they do not want to have this kind of argument. As I said, you can always take more than one, right? You can always take more than one. Yeah? Doesn't matter. You can take to satisfy both sides, program outcome and the knowledge profile, right? This is what I can tell. If you decide to explain the dominant, then the lecturer must know what they're doing and must be able to justify. But if you want to minimize the argument, is that you can take additional, right? But again, it's actually to the academic staff to explain, to justify. Okay. All right. I think if the it's just like, for example, if in the past is that some academic staff do not know why the course outcome need to be spelled out. They do not know how to assess the course outcome. That was in the past. Yeah. For example, they're using report to assess teamwork, right? So if they can use report to assess teamwork if they're able to convince the panel, right? Okay, but it's very difficult to use the report to assess teamwork. Yeah, but if they feel that a report can be used to assess teamwork, they have to justify and explain. Right, this is what I mean. Yeah, right.
Okay, there's another question. It says here that is there any overloading issue if both the final year project and also the capstone project are done in the same semester?
Okay. Some again, it actually depends on the program. Okay. Some program they can put the capstone and FYP in the final 2 semester. Somehow they appropriate they actually allocate the appropriate credits. sometimes the FYP can be, it looks like that semester, it's like 3 credits, but it's actually not. It can be 4 or 5, yeah, because of the credit allocation is not correct. Okay, and you can have two, capstone and also the FYP together, but you have to make sure that the loading at that time, yeah, is actually pretty low. For example, if they take the capstone and FYP concurrently, and probably they take 1 or 2 more electives, yeah, but not 3 or 5, that doesn't make sense, yeah. That is one practice by some institution. Another practice is that they put capstone sort of like in the 6th and 7th semester, all right, 6 and 7, and then the FYP will be 7 and 8, right? They try to separate by a semester. In some institutions whereby they have design project from year 1, year 2, year 3, then year 4 they only focus on final year project. They have their capstone in year 3. All right. Some will argue that the capstone in year 3 may not have sufficient fundamental to do the project, but for them is that because they start implementing from year 1, they have one design project. Year 2, year 3, I think this is justifiable. All right. So I normally see 2 methods put in the semester 6, 7 for the capstone, and 7, 8 for the FYP, or they put both together in the final year, but they make sure the student take less subject, yeah, for that for the semester 7 and 8.
Okay,
Okay.
on the contrary to your statement or your comment just now,
Okay.
there's a question that is that possible for FYP to be in the 3rd year? It's on the flip side.
Okay. To be honest, this one has been asked before because the title itself is final year project. So even though to me, unless it has been asked before, because the final project, because of the name is that it's final year, so it has to be placed at the 4th year. All right. Some they call that research project. I think in New Zealand they call it research project. So they do put that in the how they do this is that say you have a degree, which you can exit in the third year and 4th year. Then they will say something like in New Zealand I think in New Zealand, yeah, if you want to exit in the 3rd year, so you do until the capstone, right? If you want to complete the exit in the 4th year, all right, whereby you can register as a graduate engineer, you do a research project in addition to the capstone. I think this also present in some UK university, right? But to me, is that final project by definition is supposed to be in the final year. Yeah. All right. I think some question has been asked. Maybe one day we can, it can be accepted that it can be in another year. A research project can be another year. I don't know. So final project may change name to a research project, which can be in the third 4th year. I don't know. All right. Okay. But at the moment, final project is stay at final project in the final year. Okay. Right. Did I answer your question?
Yes, I think so. Okay, so I think no more questions at the moment, so you can resume.
Okay. All right. Sure. Now, okay. Now the thing is that we have this mapping. All right. You see some institution they what they've done is that they extend this table again. Yeah. Not again. That sounds like very frustrated. But they extend this to the right hand side. Okay. There are more. All right. And wow. It's getting longer and longer. Yeah. Okay. Now, the next item that probably present is a complex engine problem solving and the activities, on that table. Yeah. Whereby you have the WP1 until the WP7. Yeah. And then EA1, EA5, the activities. Yeah. So engine activities and the Washington problem. Yeah. Now, okay. So again, before that, we need to understand the attributes of complex engine problem. Yeah. You see, the complex problem is that I would give an example, yeah, of widely defined problem. Wide defined problem, yeah. Okay. Okay, say for example, yeah, I go to the supermarket. I know one item is 20% discount. All right. If I buy the second item, all right, then I will have 50% discount on the second item, stuff like that. Right. So this, I can easily apply formula and work out the price at the end. All right. For complex problem is that, it's just like, if you want to look for a life partner, all right, you may have your own criteria. The person must be humorous, must be must be a sport, active in sport and those kind of thing. Different people define that differently. Yeah, and then you work out a few ways. Yeah, where do I find that person? Where do I find that person? Then you work out many ways to identify. Even though at the end you have many representation of the problem, you have many, right? Because there are many different criteria, and the criteria will change, right? And many of these, at the end, you still have to make the decision, right? And the decision making is the key thing here, because everything is correct. Yeah. So at the end, the student need to be asked, why you decided on this solution, right? And after they decide, they still feel it's actually quite fuzzy, right? Okay, and that is actually a complex problem. Yeah. Here, you see here is that complex problem often lack problem statement, making task of problem definition and problem representation very challenging. Very often you have multiple revision of the problem to find the single most appropriate solution. Yeah. So this is the thing. And for engineers, we must be able to solve complex problem. Yeah. As opposed to the technician, it's just the well-defined. They follow a piece of paper, they do the troubleshooting, right? Now, you see, International Engineering Alliance or EAC put these attributes to actually help guide. It's not to complicate things. Yeah, right. The 7 attributes that you see here, 1 to 7, right? They are actually identical to the nature of the problem solved in the industry. All right. They most of the problems that solved in the industry, they are complex, right? Most of the problem. Yeah. So remember the key thing, we have the program outcomes is to bridge the mismatch in the expectation between the industry and the university. All right, that's the key objective, right? The same for the 7 attributes of the complex engineering problem is to match, the expectation, yeah, identical to the nature of the problem solved in the industry. Okay, what we can do with this is that we can always compare and contrast the problem that we set in the classroom with those in the industry. All right. So you design the assessment in the classroom, but this table here you can use to compare and contrast. Yeah, because these are the attributes of the problem normally found in the industry. Okay. Now, and these are the 7, right? The key thing here, there are 7 here, right? The most important is the depth of knowledge, right? You have others like range of conflicting requirement. You put in things like sustainability, cost, cultural, environment friendly, and so on. You put in those things for the student to look at into the design, project, for example. Because the open-ended lab that you give to them, yeah, all right, there are many ways of achieving the objective. Yeah, there basically no obvious solution. The same for the design project. When it's complex, there actually no obvious solution for that. Okay, and infrequent encounter issue. I think this is quite difficult. I think most of the time we can't really find something infrequent encounters. So, but I think what at least we can do is that we find something, through literature or whatever, there's a gap that we can improve. Yeah, for by imparting innovation, and so on into it, right? And this is a more. I think this one for civil is kind of easy. They have a bit relatively easier for those program to do so. They have the Eurocode, for example, to be applied. In this case, it will be outside the Eurocode, partially, for example. Yeah, all right, okay. And stakeholder, you see, I think some institutions, they carry out the design project. Oh, you need to have visit some potential client. Yeah, you need to talk to them in the industry. You need to talk to the potential customer. You need to do a market survey and see what actually needed in your design project. What are the preferred feature and so on. Yeah, all right, okay. Interdependence as well is a big system that with many subcomponents. Yeah. In the project, it's very easy to do that. Then in the subject base, for example, digital electronics, you may put, the combination circuit sequential and so on put together. That is a smaller, sign of sort of interdependence. But normally this is actually referred to the bigger project. Yeah, right. Okay, high level problem including many parts and sub problem. Okay. But it does not mean that we cannot have that in the individual courses. Right? We can always think about something that integrate everything that we teach the student. Yeah, right. Okay, now, so going back to the depth of knowledge, I think this is a key definition here. Is that when we want to craft assessment with complex problem solving. According to the definition here, we can use courses under WK3, all right, WK4, right, engine fundamental, right, specialist, right, no mention of K1, K2, no mention of that. Yeah, mathematics and natural science, no mention of that. You have the engine design, you have the engineering practice, you have the research literature, right? One or more of this, right? The key thing here, fundamental place, first principle, analytical approach. Yeah, very much science-based, research based for that. So by knowing this, I think the simple way is that take out physics, take out maths from the assessment of complex engine problem solving. Yeah, so make it simpler first. Yeah, I wouldn't say that you cannot use maths to do that, because some maths come with application, engine application. No problem. You can actually craft complex problem solving for them. No issue with that. Some say that, oh, mine is applied physics. I do use that to solve engine problem. No problem. You can craft the assessment to solve complex problem. No issue with that. All right. Okay. Now, depth of knowledge is a must. Then you must have the others, at least two. Yeah. By definition, the way I read that is that first attributes, depth of knowledge, and several others. Right. Several to me is kind of purer, so you choose at least two. Yeah. Right. No doubt, capstone or integrated design project can do more. Yeah. Right. Normal courses probably do two will be enough. Yeah. Okay. Now, later I give you one example. Yeah. Now. Okay. Now the pressing question is that I think I just answered that. To natural science, mathematics need to address complex engineering problem solving. Yeah. I think this is a question. But anyway, do you have this question? Because I think very often I receive this question. Right? Anyone with this question that want to get clarity? Okay. All right. If there's none, then okay. So the thing is this. WK1, WK2, K7 are excluded from the depth of knowledge. Yeah. This is what I have gathered is that natural science requires students to highlight the principle and laws, right? Okay. In demonstrating the understanding, is there someone unmute? Okay. All right. But accordingly, is that the undertaking is often too fine a level of detail to be applied in engineering activities. There is one of the explanation to why they actually excluded, right? Even WK7 here, the body of knowledge is less structured. Just now I talk about the public health safety, environment sustainability, yeah, all right, and less structure, less extensive compared to engineering knowledge. That's why it's actually excluded as well, right? Is that possible to help me unmute?
Yeah, to mute the person, please. Yeah, just 1 second.
Okay. Right, accidentally, yeah. Okay. Now, the other reason is that, by definition, is that WP1, the depth of knowledge, all right, all these here components, all right, you must have, one or more of these. By definition, in-depth knowledge means knowledge gained from courses learning activities beyond the introductory instruction level. Yeah, all right, this is by Canadian. And then the first principle are the fundamental concept and assumption, right? Meaning you have, on the theory or system method are based on. Yeah, basically those assumption that you make, from the theory and system. Yeah. So basically, the first principle actually start directly at the level of established law of chemistry, physics, mathematics, and so on. That means that actually support the the K1 and K2 need not be used for that. Yeah. Okay. Now, okay. Any questions so far about this one? Is there any, Dr. Osman?
There's none in the chat at the moment.
Okay. Now, what about complex engineering activities? I think this is simpler to tackle, right? Okay. It appear in the PO under the communication. There are a lot of argument about this. Later on, I post as a question later on. And here is communicate effectively on complex engineering activity with the engineering community, with the society at large. For example, I think very often you have the design project need to be presented openly to the public. All right, this is very good. Yeah. All right, this is good. Yeah. And when they do presentation, not necessarily we are looking at the body language, the presentation skill, but we actually looking at the how they actually convey how they undertake the complex engineering activities to the audience, right? So whereby this need to be written in the report, all right, during making presentation and so on. Okay. Now, what are these items actually? Yeah, what are these items? Okay, let me just roughly talk about it. Yeah, let me unshare. Right, I think give me some time. I hide the right now. See, there are five attributes here. There are five. All right, we need to tackle two, right? Some are all. Okay, according to the definition, is that students can encounter this during their project and even through the industry training, right? I find this quite useful because even the main definition is activity or projects, right? So if you have a capstone project, you have integrated design project, that would be the right place for you to do this, all right? So later on, I will give you one example on how to do this. Yeah. Now, I think the thing is that when if they're doing open-ended laboratory or the design project, right? here diverse resources, all right, whereby include people, money, equipment, and so on. All right. So when student carry out activities or project, so they have to negotiate for, say, the use of equipment, negotiate with the lab, officer about using the lab, and even finding out some component and so on, right? Even crafting their Gantt chart and mitigate the risk that can possibly have, those are the activities, some of the activities, right? And how do they resolve the conflicting technical and non-technical requirements? All right, how do they resolve that? Yeah. So you see, this question here, you can easily ask them, say during their presentation. Oh, how do you manage this? If you have this issue about about this issue, your solution here may put the public health safety in danger, or you normally, without realizing, you ask this question and the student will reply on that. Then they say, oh, my project here have considered this public health safety because of this and that, right? Okay, so yeah. Another example is that when we ask them, when we ask students during their YWA or presentation, we ask, hey, what is so creative about your project here? All right, then they start explaining about this, explaining about the innovation of their project, what they have done, what they have included, what they have implemented, what kind of return of investment that I get. All right, so you see the thing, they're actually doing this, they're actually doing this, right? Then you ask question, the consequences, you do this, why you not considering the lead free kind of component, the green component? Aren't you think that it will bring consequences to the society, or sustainability and so on? Basically, you are actually asking that. Basically, they are actually reporting that. But how effective? This is what we need to assess, right? Coming back to here, the effectiveness, right? Nowadays, we don't really just assess the public, body language, presentation skill, responding to question. We don't. We have to include some element of this, in the rubrics. Okay. Now, okay. So that's the thing. Understanding all the attributes of the complex problem solving, and the attributes of the complex engineering activities, right? Having done so, then we can identify relevant causes, right? That's we move to the step 4. There are actually 5 steps here. Any question at this present moment? I want to ask this question actually. Hold on. Where is the question? Hold on, give me a moment. I want to ask this question. Okay, this one. Do courses with PO must address complex engineering activities? Now the question is this: yes or no? I think this is most of the time being posted. Yeah. So what do you think about this? Yes or no? Okay. Okay. Now, to me is that it actually yes or no, because this is kind of gray. It actually depending on the practice of the institution as well. If you start from say FYP with communication, final project, is a yes. Integrated design, capstone is a yes. All right. Some open-ended lab, maybe yes. Yeah. What about those technical communication at the very beginning of the semester, right? That will be yes or no. So because you'll be teaching students about technical writing, all right? So probably about just writing engineering document, writing the proper memo, making proper poster for awareness on environment, okay. But if you think about that, if you give them a very common engine problem, they can really communicate on those activities. Yeah. So there are compulsory courses that you must have you must address complex engine activities, and there are some not necessary to me, yeah. But I know some do insist of all the courses that address complex PO on communication must have that, right? Okay, in that kind of situation, I think the problem that you give to student here, even in your year 1, year 2, you have to give an engine problem for them to work on. Then you can assess how do they communicate on those activities, right? In the event you think that, all right, the program think that my course here is to develop their communication skill. All right, you have the justification. You really want them to present well. You really want them to make proper gesture, body language. Then be it, yeah. So you can actually do it without the complex engine activities, depending on the objective of the course, right? Because you believe that with a proper gesture, body language, and so on, they will be able to communicate effectively later on. Yeah. To me, this is not, the major courses need to really address this, right? The least major, maybe yes or no, all right? If you want to do that, so give them an engine problem to solve, even in the technical writing, because they can present the problem using a poster presentation, and they do a presentation to you. Yeah. So if you have courses like English language, yeah, they're actually taught by another lecturer from the English department. I think even though it's mapped to communication, you need not have the complex engine activity, because those are to really develop their English skill, right? The communication on the English skill, right? Hope that really answer your question. It's more to the yes, but you can have a few exceptional cases on the no. Yeah. All right. Okay. Did I answer your question? Okay, if it's English language, without complex activities, are okay. All right. If technical writing, if your program owner they didn't ask you to do that, then yes, you give them one engine problem, a very common one, and ask them to do a poster. Otherwise, no issue with year 1. Technical writing, no issue. Yeah. Because you really want them to technical writing objective, you really want them to follow the format of writing, yeah, and so on. Yeah. Is there? I saw some question being flagged. Let me look at.
But,
Somehow I cannot. Yep. What question is that?
It's just a comment, I think. It says that if engineering courses, the communication must address EA.
Okay. Then if engineering courses must address EA, again, if you do not want to address EA, so why is that you do not want to assess EA? All right. Sometimes the lab report, even though you ask them to write a lab report, right? You really want them to present the finding in a proper way. Sometimes not really about the activities that are undertake. Yeah. It really depends. You have to actually give you have to understand the attributes of the complex engineering activities, and you must be able to explain and justify. Okay, it really depends. Yeah. If you are doing the open-ended lab, probably you will talk about what kind of equipment that you do use. How do you take the measurement? Where do you do that? Where do you find the resources? Why is the solution is introduce some form of innovation that will cover the complex engineering activities. Yeah. All right. So it all depends. If you do not want to do that, then you must explain why. Yeah. Okay. All right. I think for the start, always begin with the major courses. I think for the start is that I must ensure industrial training have. I must ensure capstone design project have. I must ensure FIP have. I think these are the key thing that I must do first. Yeah. After which I will look at the other stuff, right? The other courses, other assessments. Okay.
Hello.
Yes.
Can I ask
Yes.
a question?
Yeah, please.
Okay. If the lab course is a combination of open-ended experiments plus the normal experiment, can that also be considered as addressing the complex activities? I mean, the engineering activities as well.
Okay, meaning that you in that course you have a few experiments. One of them is open-ended. Am I right?
Yeah.
Okay, so in that case, you can claim that your lab actually address complex engineering activities. Yeah, you can actually say that. Yeah, all right. Not necessarily for the others. Few experiments. From there, one will be sufficient. Yeah, to begin with.
Okay, thank you.
Okay, right. And let's see. Where am I just now? Hold on now.
It's just after the poll.
Yep. Is there another post question?
No more questions at the moment.
Okay,
Nothing on the
maybe.
chat.
Okay, so can we just maybe take a short break about we come back at 10:30. Yeah. Right. I still left with 4 and 5. We come back 10:30. Is that okay?
All right. Okay. So let's let's join again at 10:30. All right.
Yeah. Right. Thank you, Dr. Osman. Thank you. Okay, Dr. Osman, can we start now?
Yes, definitely.
Okay. Now, okay, I'm going to do the last two steps. This step 5 is the implementation. I guess some of you will want to know how do we implement complex problem solving or activities. Now, the first step after knowing the attributes of complex problem solving, complex engineering activities, So you need to identify the courses and assessment. Earlier that I show you this, the the WK3, the engineering fundamental, right? I think this can be used for that purpose, and this is a specialist can be used for that purpose as well, right? Capstone integrated design project, FIP, open-ended lab, definitely fit the bill. Yeah, all right, it can be used. Yeah, right now. So okay, so basically is that you have to use the courses to knowledge profile mapping that we come out earlier with the courses to WK, and then your understanding of the attributes to identify the relevant courses and assessment. Yeah. So here, all right. So this table here is the courses to knowledge profile mapping. All right, that has been constructed much earlier, and on the right hand side, all right, here, complex problem solving, yeah, no, you just answer the question yes or no. Yeah, yes or no. Yeah. So for example, if you have digital electronics, so WK3, all right, so you put yes. All right, there is a possibility to do that. Yeah, you put yes, there is a possibility. Signal and system, right, there is a possibility as well to do so, right? And mathematics, maybe yes or no, depending whether I would say no. Yeah, all right. If it does not include engineering application in as part of the topic, yeah, you can say no for that. And this is what you do. Yes. Yeah. Basically, you can see that many actually yes. All right. But the thing is that must all courses be used to implement complex engineering problem solving? Yeah. All right. What do you think about this? Must all, yeah, because you see more yes compared to the no, yeah, in this example. Okay, more to the no, less to the yes. Okay, so as I said, natural science WK1, WK2 mathematics can be excluded. And what about the other engineering courses? Okay, now the thing is this, yeah. You have to really discuss at the program level to determine the number assessment. Yeah, there are many ways of doing it. Right? Say, in one course here, it may have quizzes, assignment. It may have final exam, and there may be lab. Right? I think it's actually very taxing for the student. If you try to do for all, yeah, assignment and lab, I think probably you need to consider the workload. I think for the to begin with, what I've done is that I always start, okay, from the assignment you have two, from the lab you have, a few. Which one you want to use, yeah, to incorporate complex problem solving. So we start with one first, all right, and see how it goes. Yeah, all right. If you have open-ended lab, I think by default that is the complex problem solving. Yeah. So we have to consider student workload. Try not to be too ambitious with that. I would say engineering courses under WK3, WK4, and so on, they can be used, but it's actually up to the program. Yeah, whether you want to try with a few subject, or you want to within the few subject, everything be inside in there. All the assessment must be complex, or just a single piece, or a piece or two. That one we need to really decide. Yeah. For me is that what I have done is that I think still acceptable by the student and staff is that, you know, if you're under WK4, WK3, you have to incorporate one piece of the assessment. Yeah. All right. Okay. Always start with a small number. Because that's human nature. You start with that, you know. They try. Oh, I think it's quite good. You know, let's work on the second one. Yeah. But again, student workload is very important. Yeah, we have to make sure the correct SLT is actually allocated for this, right? And I think some many university already incorporate them in a way, you know, like Bloom taxonomy. I do feel that the you know, there is a relationship between the two, yeah? Particularly you know, the Bloom taxonomy on the higher end here, especially evaluate and creation, yeah? Right? The reason because, you know, if I look through the Bloom taxonomy, the context of it, not very much of the action verb, you know, the synthesis is that this is a mental construction of ideas, concept from multiple sources. Yeah? So meaning it can be coming from observation, it can be coming from literature, you know, to construct the idea and so on. Then again, you see the constraint is actually given, right? It looks, you know, the context here is similar to the complex problem solving, yeah. And then to make judgment of the idea, all right, you have to make a decision of the various, you know, solution that you have, right? Using external evidence, self-selected criteria, you set your own criteria, and so on. The complex problem solving sit actually quite high up of the Bloom. Yeah. All right. Okay. Now, all right. Is that necessary to really do this? All right. I'm gonna, you know, I think you have see some sample here, you know, this way. Is that necessary to have this? Right. I provided the answer there, not necessary to me, but I think for some other it's necessary. Yeah. So what do you think? And I have my own explanation for that. Necessary to have that, and the table keep expanding to the right hand side. Even complex engine activities on the right hand side, it can keep expanding. Yeah. All right. There may be a point we can't even understand. Yeah. All right. You know what I've done is that I just put a tick. Yeah. Right. I just put a tick right there. Right. Just to tell that I have assessment on complex problem solving. Yeah. All right. Just to indicate I have that. Right. Just to indicate. Yeah. The reason because I will not tell the attributes because let me see if I have the answer here or not. Wait. Yeah. The reason because if you go back to the definition. All right. You see, the thing is that when we craft the assessment, right? I think the key thing here, we must have the depth of knowledge. The key thing here. My assessment, it can be changing from time to time, all right? It can change, you know. Sometimes, you know, I may want to do the first two, all right? Sometime after that, I change my assessment because probably student, you know, feel that my question always the same, even though open-ended, because I've done that for so many semesters. I may want to change the variation, yeah, from here, this and this, right? The assessment that we create may have different characteristics, yeah. As I mentioned earlier, so the problem, these attributes can be used to contrast the problem faced in the industry. Yeah. So say if you have a problem coming from the industry, they may have different characteristics. Yeah. That's why I opt not to take to the very detail, right? Until I limit my the innovation of setting assessment, right? So because it's so troublesome, you know, if I want to make changes after that, I have to go through the various changes, right? That's sort of a barrier to innovation, Yeah, that's why I don't put like that way. All right, but I have a way to ensure that. Yeah, later on I will tell you in step 5. Now, that is the reason why I don't do that. I just do with simple tick that way. All right, unless you have a very powerful automated system, whenever you change in your course and it get updated automatically. All right, but not many institutions have that powerful kind of automated system. Yeah. Um, all right, therefore we opt for this. Yeah. Okay. And when you make changes to the attributes, is that you don't have to get proper approval, go through the the level of approval. I think that is okay. But normally, I think program learning outcome, the mapping to the courses here, sort of is a control item. Yeah. All right. Hopefully, complex engine problem or complex engine activity, they are not control item. Yeah. All right. Okay. Because the assessment can change. Yeah. Even complex engine activities, you may give them different kind of activities to be carried out. Yeah. So it cannot be just EA1 or EA2. Sometimes it can be EA3 and 4. So do I need to do that update again? Do I need to get approval? Right. Okay. So a simple tick to me will be fine. Yeah. Now, any question at this point?
None in the chat.
Okay. Now,
Anyone wants to ask any question? Yes. Okay. There is one.
Yes. Actually, Engineer Liew.
yes.
Okay.
Prof. Shahrul. Yeah.
Sorry, Engineer Liew. I just want to. Sorry, I think I missed. I think your explanation just now. I think,
Okay.
for example, they say we are talking about the number one, the laboratory on signal, right? I think from the lab, I think we mapped to PLO 2, 3,
Yeah.
and 5, right? Yeah. And then
Yeah.
how about for that WK? I think for WK,
Yeah.
because
Okay.
does the uh that dedicated PLO, right? I think we need to map to WK as well, or how's it? Because from your
Okay.
table here,
Okay.
right? I think you have only
Okay.
WK3. Yeah, sorry about that. Okay, thanks.
Okay, no problem. I think the key thing is that you see that even though the title is laboratory, because I have discussed that with my colleague, is that he said there's a development solution. He said there's a use of tool. He said he's solving problem. He can provide proof on that. Uh, you know, even though we feel that it can be mapped to just modern tool and so on, but he illustrate this is a course. This is a 3 credit course, and I'm gonna do all this. So he has a three PO here. All right. Now, I think the question is about here. I think we see one WK6, and here we see WK3. All right. Modern 2, no problem because it's consistent, right? With WK6, all right, it's consistent. This is also consistent, no problem. I think the issue is here. The issue is here. There's a WK5 right here. All right. As I mentioned earlier, the thing is you can do 2 way. All right. Once you're done with this knowledge profile, this guy, right? You cross check with the PO. Okay, so maybe it's more appropriate, for me to put here. All right. But it's all depends, whether you just want to focus on the dominant or not. Yeah. You can put here because the program direction is like that. All right, you put it here. But I think the most important thing is that we must remember this is the laboratory to strengthen the engineering fundamental on signal and system, right? And give them the lab work, which is the engineering practice, right? I think this will be the 2 dominant one, but this one here probably just to fulfill the direction of the program, you can put it here. All right. I think some program they can explain, the staff can explain that. I just want to focus on the dominant the component because my subject here is addressing the curriculum content on fundamental and engineering practice, right? And this is my focus. Yeah. I do not want to include this. It's okay. Yeah. No problem. Yeah. Right. I can also choose to take 3. No problem as well. Yeah. But I think ones must know what they are doing and able to explain that. Okay. Right. there are a few ways of doing it. I think one of the way is like Prof. Kamal suggested is that you have here, then here must be consistent. That's okay, right? But we must know the dominant knowledge profile the course trying to address. Okay. Okay, Prof. Kamal, is that okay?
Yeah. Okay. Thank you, Generally.
Okay. Right. Now, let's see. All right. Now, how do we actually implement complex problem solving into the assessment? Yeah. Now, how do we implement? Yeah, I think there are many ways of maybe I take some response from here. Let me clear here. So, how do you do that? Using what kind of teaching and learning activities, the type of the assessment. Okay, we will example. That is the example. That is the industry-related problems, case study, open-ended question, right? Team project-based learning assessment. Okay, project-based learning assessment. I think this is quite true. You can give them case study. Okay. Now, okay, so there's one more coming just now. Open-ended project problem, project-based assessment. I think these are all valid, right? Okay. Now, how do we?
I Liew, there's a question that would EAC accept that mapping?
Which mapping?
I think the one that the complex engineering one.
Is the
I think
mapping
the one,
that I showed earlier?
yeah.
This one? Is that this one?
Yeah, I think because
This
the
one?
question is rather brief. Would EAC accept this? I think it means this one, the compact one.
Okay. You see, the next thing is that if I say I have this subject address complex engineering problem. I have this project, this subject here address another subject address complex engineering activities. The next step is that I need to show it. Yeah, I need to show the evidence, right? So the next step I'm going to show you, I'm going to talk to you about is how to show that, right? Okay, so this is what I've done. All right, I do a ticking. I actually do a way. I make it as simple as possible. Yeah, I even can take this entire thing, and I can tell the panel say that all our fundamental subject WK 3 and 4 have at least one piece of assessment with complex problem solving. I can even say that. Yeah. All right. I can even say that by removing this. Right. If I'm confident enough, I can do that. Right. Otherwise, this will help to identify where is the complex any problem. After which, then we have to show them. Yeah. My next question, I want to the next step here is how do we provide the evidence, right? Okay, now the thing is this: how do we ensure implementation? All right. So first, you have to really identify the courses, right? WK 3, 4, 5, 6, 7, 8, and what are the associate assessment. So the first thing is that you have to revisit the assessment rubrics, right? Or explain in the assignment, mini project, and others that how complexity is addressed. All right. Okay, I'm going to show you these two. Yeah. Now, and any other ways. Yeah. Now, first, you can actually describe in your assignment. Yeah. All right. So you describe how you do that, how you address complexity in your assignment, right? So this is a first page of the assignment, right? After which, what I've done is that, can you explain, how do you tackle all these attributes, right? I get my colleagues to do that. After that, at the very beginning, it's very painstaking because I have to sit down. Somebody need to sacrifice. Somebody need to do it. Now, somebody need to volunteer. All right. I mean, we go through this one by one. All right, and then they explain. Okay, they explain. Oh, because I need to use sequential circuitry to design a counter, from the very first principle. There's some element of design as well, or using the tool as well, even though this subject here is WK3, right? But there's some coverage of WK5 with the design and also the simulation. And then he went on to explain, right? Went on to explain, yeah, and this, all right? This is not enough, and they have to explain some more, because the key thing here is that you must have WP1, yeah, and then you must have the others, few more from here, right? So WP3 depth analysis. There are some consideration on designing digital clock, what to be used, and 24 hour 12 modes, and there are a few ways of doing this. Yes, in fact, at the end, the student will present, even though it's in the group, they have a different way of doing it. Yeah, all right, and it's so difficult. So here, so difficult to tackle the rest. So I end up with WP, P7. I will tell them, there are a few sections, starting from the BCD, starting from the counter, decoding the 24 hours. I will just explain. Students ought to understand relationship, right? When they write the report, they have to explain all this, right? Okay. Now, even though it's not really high level at this WK3, but but the student actually sort of to interconnect the different sections, in the report, right? So that is still not enough, because that's just on the surface, the staff may want to do that. So how to do that? You have to cross check with the assessment rubrics, right? Cross check here, meaning that if you say if they say they want to do depth of analysis here, they're talking about this, consider different type of flip-flop, the option, how they implement, they have to be reflected in the rubrics. Yeah. All right, have to be reflected in the rubric. I think this is another one, another rubrics that I'm saying, is that I just want to make sure that what I'm doing here, the evaluation criteria here, all right, on the left-hand side, whether it's actually addressing the attributes or not. Okay. I think this one is capstone. I didn't use the same one. Sorry, this is an integral design project. For example, constraint. Right, I want students to talk about constraint in their report, and this fall nicely under range of conflicting requirement. Okay, I want them to do literature review. This one fall nicely under depth of knowledge. Yeah, and so on. I want them to talk to people. All right, okay, people about all these things. I will put in the stakeholder. Yeah, even though I need to spell out the user. Yeah, right, user, client, right? I ask them to talk to them. Okay, and then say implement engine design solution, identify possible solution. Right, I want them to consider all the possible solution. Right, this is a depth analysis. Just to make sure, I need not put this in. I need not put this in. Yeah, but I want to cross check whether I'm doing that or not. Yeah, all right. Otherwise, what I'm telling here, all right, if I'm telling here, this is what I plan to do, but the rubric does not drive that, right? So I need to cross check with my rubrics whether is there any enhancement I need to make, whether any additional I need to make, and so on. So I need to ask that question. Very often I need to include just one or two more only. Very often, yeah. I have done that. It's just including one and two. It's not portal revamp. Yeah. Okay. Now, what about complex engine activities? Right. Again, same thing here. You always start from the program level, right? Particular on the complication PO. Okay, and we have to revisit the rubrics to drive complex engine activities, right? So this example, remember for complex engine activities, always use project or industry training. I think there's one avenue here, and what I've done is that I use the existing rubrics, right? And okay, now the next thing that I do is that this is a right effective report design in the complex and undertaken in the workplace, right? Meaning this is industry training. Okay, all right. I will say in engine activities. So after which I look at the rubric again. Normally, students do the introduction, about the report, the company overview. They do the conclusion about their work. Normally, communication, we assess report organization, formatting, language, all this stuff, right? But somehow I need to include some engine activities to be there. Like task performed, right? Discussion and reflection, right? Even logbook itself, they are talking about their activities they are taking, right? Even logbook itself. So I want to again I want to cross check what I'm doing here. You see whether is any EA there, any EA here, or any EA engine activities right there. So after which I need to do enhancement, right? Right? Because if you see here, I have not put in whether this is EA1 or 2 or what. I did not. Yeah. So the thing is that yes, I think I sort of have it. All right. I sort of have it, but now I want to follow what being described in the EA, right? So basically, what that we are having already have it, yeah. But we just need to do alignment or improvement to that, right? I think when you have a report without this thing here, right? Without this thing here, it will be a normal report checking on references, checking on the report organization, checking on the report formatting, which we do not want. Yeah, all right. But we have to include this into there, describing all the activities in here. All right, so that student will pay attention when they write the report. Right. Okay. So other method is that through team moderation. Is that after the accurate staff had done so, it will be moderated. It will be moderated by a team of people. I think I've seen this as well. Yeah, depending, the manpower that you have. But I believe in educating the the other staff about how to set the appropriate assessment. Okay, some able to do that, but some institutions they can't do so because of the minimum staff they have and things like that. Yeah, right. Moderation means that you look at assessment, right? You don't do all this. You don't do all this moderation. The moderator will check. All right. You don't do it all. You don't do all this, but the moderator will check. Yeah. Right. Okay. Now, okay, any question? Yes, I think my next question is that do we need to address all attribute or characteristic of complex problem solving and complex engine activities? Yeah? So we have WP1, to WP7, we have EA1, to EA5, do we really need to address all this? What do you think?
You mean in the whole program?
In the whole program as a whole. You say here one subject. We have one subject.
You address some only.
Yeah, WP1, WP2, WP3. Another one maybe WP1, WP4, and P5. So you have to ensure all this being addressed. All right. Okay. I'll say yes. All right. Okay. Many say no. Right. My answer is more to no. Yeah. I think the level of detail has gone too much. Until we need to address all. I think the key thing here, the PO must be addressed. Program outcomes, right? Ability to solve complex problem is a must, right? Attribute is not really, yeah. It's not really, yeah. As long as we, can compare and contrast our classroom problem with those of the table WP1 or the EA1 to EA5, that would be sufficient. Yeah. Even some, like for example, the extent of applicable code, yeah, whereby you have to use the code. Program like Civil very easy, they can do that. But some program they can't. Yeah, you can't be forcing them to use the code. As part of the complex problem solving. Yeah, some they can't really demonstrate that. Yeah, some program. So I would say keep it simple. As long as it's a complex problem, that will be all right. I think we are going too much detail if we, I don't know. So keep it simple first. Is at one stage maybe everyone is ready, then we can cover all the attributes. Yeah. I don't know. So I may offend somebody here, right? To cover all attributes. But that's my opinion because it's very difficult to do all and cross check everything. Yeah, it's very difficult. Yeah, even setting complex problem is actually quite difficult. And then we must ensure all attributes are addressed in the entire curriculum. Is another difficulty. But anyway, capstone project or integrated design project will address most of the attributes. Yeah, you will see carefully, it will address most of the attributes. Maybe one or two is left out, but most will be addressed. Yeah. Okay. All right. Now, okay. Any question at this point?
At the moment, nothing in the chat. Perhaps
Okay.
anyone wants to ask?
Yeah, verbally. Yeah.
Okay, I think you can continue
Yep.
first.
I think yes. Okay. The key thing here we have to know is that the program outcome is a must. Okay. All right. Student need to demonstrate it at the end. We have to address all components of the knowledge profile. Remember, this is a minimum knowledge. This is a minimum being specified. All right. Therefore, we need to address all. Alignment of the assignment projects. Open-ended lab, we emphasis on WP1 and some of the other attributes. With the user assessment rubric. All right. It's I want to say this is actually driven from a program level. The owner of the program, with the knowledge profile, with the curriculum that you taught, and this problem-solving capability that you give to the student, you will be able to demonstrate the TEL EAC program outcomes. Yeah. For example, analyze complex problem, right? Okay. And there's one thing here about the new PO knowledge profile by 2024. I think you have to pay attention to that. Is that there's one coming out, but I don't think they're very much different than the earlier one. Okay, just that the element of social science has come in, right? Because of the Sustainable Development Goals, right? Okay, SDG, right? And engine design have a lot of SDG being incorporated in there, right? You see, the role of society issue, there's SDG being mentioned. Okay, Literature, I think is still okay. I think the rest still the same. But there's one new is on the ethics and behavior conduct. All right. Here about ethics, diversity, gender, physical ability, and so on. All right. This will be under a new profile. Yeah. Again, I don't see this is very difficult. Because I can see PO8 being, by the way, there are two PO will be merged. Yeah, the PO on engineer and society, engineer and society, and environment and sustainability will be merged. Yeah, and sustainability will be merged. Yeah, as under one PO. Yeah, so I don't see any issue here as well because of the merging. But ethics here will be the PO8, the current PO8, and you will see teamwork being added, teamwork being added, yeah, as well. Can't remember about communication, yeah, but teamwork being added as well, yeah, because diversity and so on. Lifelong learning has been tagged to, lifelong learning, PO on lifelong learning has been tagged to WK8. Right, it makes sense because only through research literature, um, only through lifelong learning, I think you can encourage literature review and so on, yeah, as in tagged. Yeah, so take note of that. All right, to summarize is that not to get confused with anything. So always treat the knowledge profile as the component of curriculum, right? As I said earlier, you must have all the courses under WK, courses tackling WK1 until WK8. Some very minimum courses, for example, WK1, natural science, maybe you have a few, that's okay, right? Maths, maybe you have 3 to 5, that's okay, right? You maybe have a bit more on WK3, is okay. A bit more on WK4 is all right. WK8, maybe a few, because of the research literature, maybe 2 or 3, that's okay as well. Yeah. So, but as long as we can cover all, yeah, the knowledge profile component. And remember, there are other courses that we need to demonstrate program outcome. For example, there are some assessment you design for lifelong learning, research method, teamwork, communication. Those are the other courses, right? Remember to align the courses with course learning outcome and align to program outcome, right? Then with the knowledge of the complex attributes, so you can design an assessment with required characteristics. Okay, because through assessment, students are able to assessment and teaching and learning activities. Students are able to solve complex problems and carry out engineering activities, right? But the knowledge profile will ensure that, because we need to teach them some fundamental, actual science in order for them to do this, to solve complex problems. Yeah, so they are related. These two you add together, and then I think the key thing here is to demonstrate detailed program outcomes with the ability to solve complex problems. Right? Okay, so this is a summary of that. They are all different things. Yeah. Okay, and Ashen, I think that's the end of my slide. Yeah.
All right. There's actually one pending question. Okay, it says here that as capstone project addresses most components, what is the minimum credits it should be assigned to if the capstone is actually done in only one semester?
Wow. Okay. You see, the thing is that I think for most the capstone project, I would share in some discipline, like chemical, I think, or civil, they already have the capstone in place. Yeah, since the very beginning. For electrical electronics, it's sort of like ad hoc that we add in a bit later. That's why sometimes we end up with one semester kind of capstone, 2-3 credits being allocated, there's no restriction about the capstone, whether it can be done in 1 semester or can be done in 2 semesters. So the credit hours really need to sit back and take a look on that, because capstone is an important subject. It's very much to the design and build project, and the FYP in the past, especially for electrical, is more on the design and build. So we have to change that. We change that to research type and put the design and build under the capstone. So therefore, I would see the capstone project, supposed to have a bigger credit hours. Supposed to have a bigger credit hours. Yeah. Normally, I would see about 4. Normally, I would see about 4 credits, like that. Okay, is that 3? I think 3 maybe. Sometimes I see 2. Yeah. Because on paper it may be just 2, but when students undertake the project, is they are equivalent to 4 or 5 credits. And if it's 2, probably student won't pay too much attention as well. I think there's a relationship for those things. Yeah. Okay.
Okay, so
will I answer your question? Yeah.
yeah, Dr. Lim Cheng Siong, do you have a follow-up question on that? Okay, there's another question here. Some PLOs contain the phrase complex engineering problems. Is it necessary to map complex problem to these PLOs, or is it sufficient to show which course addresses complex problem?
Okay, the thing is this. You see, there are some. Remember, PO is actually attainable at the end of the program. The thing is that in the past, we always believe that those courses, in the year 1, I think this belief still holds, is that in the year 1, year 2, year 3 is to support the attainment at the end, which need to be demonstrated at the end. So the same for complex engineering activities, that I can use the fundamental course at that level for the student. I can give the example of ask them the building counters. I add in the element of complex attributes. At that level, it's actually complex for them. Yeah, but when they go to the 4th year, say they do a capstone, the complexity here, sort of, increase, where they need to consider, the almost everything, all the constraints from public health, safety, environment, even cultural. They have to put in everything together. For the fundamental, maybe the number of requirement will be smaller. All right. The example that I show, maybe consider the type of feedstock, consider the type of availability in the lab, consider the speed. But when you go towards, say, the 3rd year, 4th year, you have to consider all the constraints. Basically, from ergonomics, from culture perspective, and so on. It's very limited at the beginning. At the end, will be much more. And yes, I think for even subject like fundamental, you can actually do complex problem solving with limited constraint, with limited number of solution they can come up with. Yeah, but as you move to the higher level, this will be more to consider, will be more difficult to make decision, will need to make more judgment in detail, right? So I'm not sure whether I answer your question. All right, you have. Do you want to ask further?
No, thank you.
Yes.
Okay, says
The
that.
thing is that the thing is that we cannot actually use the fundamental subject to have something really complex, but we can really use the attributes. For example, WP2 range of conflicting requirement. At that time, maybe about for fundamental, maybe about 3 conflicting requirements. As they go on to the capstone, they can have more 5, 6, 7, or maybe other conflicting requirement that you can put in. Yeah. Yep.
Okay, it's time for Q&A. So if any of you got any questions, yeah, just feel free to, put your questions in the chat, or you can just ask directly.
Okay. There any?
Hi, Engineer
Yep.
Liew,
Yes.
Rubinta here.
Right, Prof.
Maybe you want to emphasize to the audience as well,
About
where we do the mapping for complex problem solving, because in the table, in the standard, it is written that if we include complex problem, which has the WP1 characteristics, it must also include some other WPs.
Yes,
Because some of us, even we also do some few mistake where we only address WP1. So that was highlighted by the AC panel last time.
Okay, let
So
me
might
just.
be, you might want to emphasize that to the audience as well.
Okay. Okay, let me just look at the what I have here. Okay. Okay, let me just unhide this, right? Okay, the thing is I didn't include it because I think the focus here today is about alignment. I think this we really need to understand what is this range of conflicting requirement that I talk about. I think we'll take this opportunity to answer the question earlier as well. You see, for the fundamental subject, yes, I will have a range of conflicting requirement. I have to pick one. You see, for a capstone project is that because it's culminating, if you look at the wide ranging, basically everything wide ranging meaning. But for very normal subject, in the fundamental, I cannot be too wide ranging. Probably a few conflicting requirements. Yeah? All right. Then I will start from there. Few conflicting requirements. As I move to capstone, there will be more. Yeah, even your FIP, that will be more. Yeah. All right. Now, the thing is this: you need to have one of these. Yeah, you have to give them conflicting requirement. So, for example, low cost. Yeah. For example, is safe to operate. Yeah. These are the things that you can mention to the student. Yeah. And this is one example here. Okay.
I'm sorry, but there's no sharing of slides.
Oh yeah. Okay, lupa dah. Hold on. Okay, nanti jap. Okay, now. You see, this we have to know this what is actually range of conflicting requirement. And this is the wide ranging. Wide ranging is actually referring to, if you're doing FIP or capstone, then it could be wide ranging. But for fundamental course, I cannot be too wide ranging. I have to limit the range of conflicting requirement that I'm going to give to student, the constraint that I'm going to give to the student. Right? Probably I give them the few. Right? Now, some of these will be like low cost, safe to operate. All right? Environment. Yeah. Even particularly, the outlook must be pleasing, right? Easy to operate, disposable, and even cultural, like, cannot undue pain and so on. This you you can incorporate. For the capstone, very normal. Normally, student will actually evaluate their design based on all these things. Yeah, anything they can think about. Yeah, this is quite wide ranging. Yeah, and if you address WP3, normally this is called the depth of elasticity. It's a very deep, kind of thinking here. There's no obvious solution because, say, if you give them open-ended lab, very likely this will be addressed. They need to consider multiple, solution to solve a problem, and you can incorporate that, into your rubrics. Yeah, and you have other stuff like, familiarity of issue, which can be new problem not previously encountered. I think you can be familiar, all right, with some unique issue that make resolution more difficult. Yeah. So this maybe they can identify through literature there or talking to people. There are some issues that they need to address, right? Very unique. Yeah. Now, also have codes, right? If you have something, I think electrical probably you have the electrical wiring codes that you need to adopt in the wiring, but the thing is that what if the problem given to you, you have to really it does not actually governed by the standard and codes, right? So when that situation happen, they need to apply the skill that they learn, yeah, from to address some part of it, yeah. So this is the extent applicable code. You also have the, I think this is quite easy, is the extent of stakeholder involvement in that. For the engineering is that it has to be diverse, yeah. The direction here has to be diverse, even though now at the moment it's very few groups, yeah, with verifying needs, right? For example, capstone that student need to do the market survey and so on, talk to the potential client, the user, and so on. This need to be recorded in their report and so on. Yeah, right. So the key thing is that you have to when we craft the problem is that we have to address the WP1, the depth of knowledge, yeah, and we have to show them how do we tackle the other attributes. So how do we show them? I think the best is that you still come up with the thing that I just said, yeah, right? Like this, mention in your assignment, mention how you do that for WP1, mention how you do that for the others WP, right? So I think that will stop the question, all right, the further question, yeah, because you have really think about it and put it in a table form, right? So in addition to that, make sure the rubrics actually align to that, really addressing what you, really addressing the problem solving capability that you want to see in the student, right? Okay, Prof, is that okay, Prof? Yeah.
Yes, because from the slide that the next slide just now, the one that you have a few WPs at the end.
Yes.
The other one, the rubric with the WP.
Yeah, this one. For me is
this one. Right here we see WP1. We have WP1 and other WPs in
together
in this particular course. Yeah. So this is the thing that we have to have, where we have to have WP1 along with some other WPs, not only WP1.
All right. So you see that I just want to cross check that. I have WP1 and P3, P6 and P2, right? But that will be the first step. After which I may want to do all this here. First step is that I'm gonna apply and see what happens. After that, I may enhance this. Yeah. Okay. So it must be matching to that. For example, external stakeholder involvement. I may, you see client and user being mentioned, right there. Yeah. All right. So if the range of confidence, all constraint criteria assumption, it need to be consistent with that, right? Okay. I think by doing so, I think we can convince ourselves, not only ESC, that this is what we are what we're doing is correct. Yeah.
Yes, thank you. And we might want to use this kind of template to improve our rubrics
All right.
later. As we
Okay.
are in the midst of curriculum review.
Yes, you can use this, but again, my worry is that always when an institution come out with this template, if they thought it's gonna be it's gonna be a must. That's the problem. The thing is that we do cross check. All right, we have to remember this. This is the thing. We do cross checking because we want to ensure that it's actually aligned to the
Yeah.
complex attributes. Yeah.
Yes,
All right. Okay.
that's true. Thank you very much.
No problem. Is there any other question?
Yes, we can still take one or two more questions.
Yes.
Okay, going once.
Okay.
Okay, going twice. Okay, all right. Okay, so since there are no further questions, I would like to take this opportunity to thank Ira Liew, okay, on behalf of the School of Electrical Engineering, okay, for giving us such a comprehensive talk today. Okay, and I hope this will be beneficial to all of us. Okay, in
Okay.
what we call designing our courses and fulfilling the requirements of EAC and making sure it is up to the standard lah, right? And so before we end this session, so why not we just turn on our cameras and just take a group photo together? Is that okay?
Okay. So I will send you my slide. Is that okay? Do you guys want to refer to my slide? I'll send it
Definitely.
to you guys.
That would be
Alright.
very beneficial. Yes.
Okay. Sure.
All right, so we have many participants today, over 100. Okay, over 100 today. So okay, so it was okay, not only from the School of Electrical. Okay,
Okay.
okay, so I'm going to take the photos. Okay, so this will be on the first page. A smile. All right, so let me go on the second page. Just 1 second, please. Smile. All right, on the third page. On the fourth page. All right. Okay, so again, thank you very much, Doctor, for having us. Okay, and
Sure.
giving this talk. So we hope to see you again next time.
Okay,
And I
sure.
hope this approximately 3 hour, 2.5 hour session was really beneficial to all of us. Okay, thank you very much.
Okay.
Okay.
Right. No problem.